Now question 7. So, three identical spheres, A, B, and C, are placed on plastic stands as shown in the diagram below. The charge on sphere A is positive 5 nanocoulomb, sphere B is a negative 8 nanocoulomb, and C is a neutral. So remember, a neutral sphere, it has zero charge, right? So the three spheres are brought into contact with each other and then separated. So very important, brought into contact means that there is a new charge. So 7.1, 7.1.1. They said calculate the net charge on each sphere after separation. So after separation, they had a new charge. So it's also a net charge on that sphere, right? So let's say Q net, since they're talking about the net, is equals to one sphere, that is charge 1, plus the second sphere, charge 2, plus the last sphere, which is charge 3, over how many spheres? 1, 2, 3. That means we divide by 3. So the charge on sphere A is positive 5. So that is 5 plus the charge on sphere B is negative 8. So let's put it in bracket, negative 8, plus the charge on sphere C is 0 because they said it is neutral. So we divide by 3. So 0, okay. 5 minus 8, that is negative 3. Then negative 3 divided by 3, that is negative 1. But since the charge is given in nanocoulomb, so we convert it and make it 10 to the power negative 9 coulomb. So this is the net charge on each sphere after separation. Then 7.1.2, calculate the number of electrons in excess or deficit on sphere C after separation. So since now they have the same charge, sphere A, sphere B, and sphere C, they have the same charge. So the number of electrons equals to the charge on over the electron charge. And then the charge on sphere C, we said it's what? Is negative 1 times 10 to the power negative 9. So it's negative 1 times 10 to the power negative 9 over negative 1,6 times 10 to the power negative 19. So this one, it gives us the answer of 6,25 times 10 to the power 9. This is electrons. So you can write electron in weights full, no problem. Okay, and then second statement, they are then placed a distance apart as shown in the diagram 2 below. So these are the charges now that are in distance from each other. And then 7.2, draw a vector showing the electrostatic force acting on the charge B due to the presence of A and C. So it means that A and C now they're exerting a force on B. So we want to see where is the direction of the force exerted by A on B, where is the force exerted by C on B. So that means now we have to draw the vector diagram or the free body diagram. So now we represent it by dot. This is sphere B, or the charge on B. So let's check now. Due to A, since remember we calculated the new charge, it means that now we focus on a new charge. So these three spheres, they're having the same charge, which is negative 1 times 10 to the power negative 9. It means that all of them are negatives. So since all of them are negative, it means that these are like charges. So like charges, they repel. It means that A will push B to the right. So this is the electrostatic force A on B. And then C will push B to the left. So this is B going to the left. So that means that this is the electrostatic force C on B, or you can say FC. That means that it was exerted by C. So the last question, 7.3, to calculate the net electrostatic force on sphere B. So we can use this space this side. The net electrostatic force, so we can divide here. So 7.3, we must calculate the net electrostatic force. So the net electrostatic force, first let's calculate the electrostatic force exerted by A and electrostatic force exerted by C. Separate. So let's say this is the electrostatic force exerted by A on B. So this is K, Q1, Q2 over R squared. And then K, that is 9, is constant, 9 times 10 to the power 9. So the charge on sphere A, since they're having the same charge, that is 1 times 10. Remember, we ignore the negative. Times 10 to the negative 9. Even the second one, 1 times 10 to the power negative 9. And then we divide. Let's check the distance between A and B. This is 15 centimeters. So 15 centimeters is going to give us 0.15 when you divide by 100. And then the answer, this one's going to give us 400 Newton. But then let's check, where is the force, electrostatic force A on B? This one is going way to the right. So it means that now we're going to say this one is going to the right according to the vector diagram. And then now the electrostatic force exerted by C on B, so we can call it FC, is equals to K Q1 Q2 over R squared. And then our K is 9 times 10 to the power 9. And then since they're having the same charge, 1 times 10 to the power 9, negative 9. Even the second one, 1 times 10 to the power negative 9. And then we divide. Let's check the distance between B and C. This is 20 centimeters. So 20 divided by 100. This one's going to give us 0.2, then squared. Don't forget to square. So now the answer, that is 225 Newton. So let's check the force exerted by C on B. The force exerted by C on B is going to the left. This is left. So we're going to say this is left. And then since the question said you must calculate the net force, now this is where we're going to say F net is equals to the force exerted by A on B plus the force exerted by C on B. So since we said the force exerted by A on B is going to the right, it means that we're going to take right as positive and then we take left as negative. So this is 400 plus, and then this one's going to the left. So it's going to be minus 225. And then the answer is going to be 175 Newton. And then check. Since we took right as positive, now the answer is positive. It means that our net force is going where? It's going to the right. So this is the end of this question.